Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And as always, this is the series where we are creating a programming language from scratch. That is, we are using just our basic skills of C++ and hopefully some modernish C++ and tools like Flex, Bison, ICU, Google Test, things like that. And of course, Vim is our editor, so we are just working in a terminal window. And today, well, we've been doing a lot of work with strings and Unicode stuff, and I wanted to get back to some of the core features of the language. And one of those features that exists in quite a few languages is the ranged for operator. And the ranged for is a way of automatically iterating through the container, a container of some sort, in a for loop. So rather than having to use an index to count through, you use this ranged for item. So that's what we want to do. It's going to take a little bit of work, and well, what's new? Anytime you add a new feature to the language, but of course this is our language, so if we don't write it, it doesn't exist. And of course, Tang is meant to be a template language, so we want it to be user-friendly and straightforward. Now, a lot of languages will go back and forth. They will, for the ranged for operator, they will use the keyword in and of and a lot of different things. I actually prefer the terseness of C++'s syntax with a colon. So that's what we're going to do. We're going to use a colon, and in order to do this, we're going to have a new AST node type. We're going to have a what else? Well, a new AST node type. We're going to have a couple new computed expression types and a couple of new opcodes. So yeah, we were going to need to jump in. But there's one other thing we need to do. I've always said there's nothing up my sleeves, right? My sleeves are hidden, so you can't see that today. But anyway, this is 100% live programming, which means you see all my mistakes in all their glory, good or bad. And in this case, normally I would go to the window and say, look, hello. There we go. Git log, and the last commit I did was the end of episode 52, and that is not incorrect. I mean, that's the last one that's there. And then I will then say git status and show that, ooh, there is actually in this case a change. Let's see what that is. Well, what it was is, if I say git diff, we can see when I was scrolling through the last video, doing the final edit, I noticed that there were 2 blank lines, and I didn't know why. And so I looked up to see these code points, 10,214, 2,215, and then it jumps to 10,218, and there were 2 blank lines. And yes, they were missing. Have no idea why, but they were missing. So I added them in, and then, do you see the spacing is wrong? Yeah, the spacing is wrong. So let's look at this. Not git, vim, flex, HTML escape, ASCII. And if we look, all of these, if my cursor isn't making it all the way over, you notice? You know it here. Let's see, git diff, just so we can see where is it? Around line 1029. There. These two. Those two are the new ones. Lang and Rang. You see how I can go to either space there, and yet if I go up, I can't. Why? Because those are tabs. I despise tabs. No, I despise hidden things, and tabs are may just be my opinion, but I don't like them in programming because you can't see, they're doing something and you can't control, well, you can control it, But I'm not going to rehash the entire argument. Basically, in general, my philosophy is if it's doing something magic, I don't like it. So I would rather have explicit spaces, and I don't care if it takes up more bytes to represent. I know what it's going to display as, and that's what I care about. So in this case, I don't like the fact that there's tabs for each one of these. So we want to change it. How do we do that? That's a very good question, because if I, okay. So I think I can hit Shift V for visual mode and then %. Yes. That will select everything in that block, and now do the unindent. Now Shift V %. If I hit equal, will it? No, it did it a little too much. So hit U to undo, Shift V %, and now that indented everything, and now I'm just going to kind of undo the first one and the last one. There. All of those that were tabs are now spaces. See, I can navigate between them. I couldn't do that before. So get status, get diff. See, all of these. Yeah. Go down. I don't care. Get commit -am. Replace. There, that's the first commit. in GitLab, no, that's work uses GitLab. GitHub, if you see anything that where in the contribution, the additions and subtractions graph, when you see it both go out, that's usually a big refactor. That's a big refactor. Oh well. All right. Now we want to get to our ranged for. And usually the easiest place to start is in the test document. And just so we can figure out what we're trying to write. Just looking for the word for. There's control flow for. I may start here. Just yank 7. And here, let's just. All right, I'm going to do what I started doing previously, and that's, doing this little indentation thing, and we're going to have a range base for, and here, let's even call it ranged for, and A is going to be 1, 2, 3. An array of 1, 2, 3, and what do I want this syntax to look like? I think I want to give it a variable and then a colon and then what I'm iterating through. And all I want to do is print num. All right, and evidently this should be P1, execute, out, and it should be the string 1, 2, 3. That'll be the first one. It's going to fail, but that's okay. Well, that'll give us a starting point. So on the right-hand side, we're going to make clean, make test watch, and let it get started. In the meantime, we know that we're about to have to start editing Bison Flex. So we need an AST node. All right. So what's this going to look like? Let's copy the include for the AST node 4. And let's call that AST, no, include AST node ranged 4.hpp. And we're going to do the same thing with the source src for AST node 4, and we'll call that source AST node ranged 4.cpp. And we know we're going to need a computed expression. We're going to need 2 of them. Copy the include for computed expression. Which one do we want to use? See what it is, we're going to need an iterator. So when the thing is the for loop is doing a lot of magic in the background, and I just said I don't like magic. I don't like it hidden. As long as I wrote it, I'm okay with it. But what it does is it says, okay, here's a collection. Maybe it's an array, maybe it's a string. We're trying it with an array first. But I want you to give me an iterator, and an iterator is something that can hold its own state, and I can then say, okay, give me the next value, 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 over and over until it gives me an ending value. And that's what we need. We need a computed expression iterator. But what are we going to copy it from? Let's do an array. Include computed expression, and we're going to call this iterator.hpp. And I'm going to do it again, but instead of array, no, I'll still use array, but computed expression iterator end. Okay, and now copy source computed expression array, source computed expression iterator.cpp, and then do the same thing, but iterator end.cpp. All right, so that's 3 things: an AST node for the iterator, no, for ranged 4, and then 2 computed expressions. Let's edit the make file. So the AST node ranged 4, probably put it right before the return. Ranged 4, and then the computed expression iterator. So after integer. All right, this will be iterator end, and then go back, iterator. So that's the 3. We need to write our rules for them. So why did I do it that way? For this, ooh, there's a, no, that's probably fine. Let's do a change. Oh, do I remember how period, comma, period plus 4 %s, and this is going to be, what are we going to change? Return, and it's going to become ranged 4. Evidently, I don't remember how to do this. Or is it 4 plus? Dot? I don't think so. Oh, S. There we go. Not a %s, just an S. All right, and so that's the ranged 4. And then what's the other one? The iterator. There we go. Oh well, should have just written it. This is going to be integer, and it's supposed to be iterator. And then the next one will do this same thing again, except it will be iterator end. Okay. Now, it's not going to like that because we're going to have doubly defined things, and that's what it just gave me. So let's start fixing some stuff. So now we're going to edit the include for the AST node ranged 4, the source for the AST node ranged 4. All right, the include for the computed expression iterator, the source for the computed expression iterator, the include for the computed expression iterator end, and the source for the computed expression iterator end. Anything else? Yeah, we're going to need to do the opcodes. We're going to one thing at a time. Let's tackle this first. Okay, so this is the ranged 4. So the node 4 needs to become node ranged 4. It needs to become node ranged 4. Okay, and we'll do the same thing for the all right, so what will this look like? That represents an if for. So it really only has two parts. It has the variable. Let's just do it this way. Param target the target variable to hold each iteration through the loop. Oh well. Through the loop. And also collection. There you go. And I don't need I do need the code block and the location. That should work. So target collection code block location. Target collection. I don't need this increment thing. Code block location. All right. Need to be able to dump it. I need to be able to compile it and compile pre-process it. That's fine. I don't need. Well, this is the target. Iterated value isn't. To hold the value for the current loop. Iteration? Is that better? Maybe. I think I like that better. So the target variable to hold for the current loop iteration. Okay. And that's going to be target. All right. Now, condition, not condition, this is collection. And this is going to be the collection through which I did that same thing, through which to iterate. We don't need the increment. So the code block, that's fine. Okay, I think that header is good. Let's go to the next one. We've got to do our substitution. This node, that should work. This is going to get a little ugly. Let's just go. Okay, so the range 4, it's not initialization, it's target. You know what? Let's do this. Let's change all and itializ initialization to target. Okay, we'll do it the same thing. All I don't remember condition. So all condition %s condition. That's going to be the collection. And then we don't need this increment. There we go. Well, we have target collection. Don't need this increment. Code block. All right. This is going to be a ranged 4. So indent plus the target. There we go. The collection. Don't need the increment and the code block. All right. Let's come back to the compile. For the range 4 compile preprocess. Target collection, don't have increment code block. Okay, we're back. So what should it look like? This isn't, yeah, it's not going to be happy until we sort out this ranged for compile. So yes, it would make sense that we break and continue because it should work there. Oh, in fact, we should write a test to make sure our break and continue works in the ranged for. Do we need to compile the target? No. The target... I'm getting a call. I need to pause the video. I'll be right back. All right, I'm back, and now I've got to get back into the zone of what I was doing. What we're looking at is the compile statement, and what do we need to do? We changed the names, by the way, so we don't actually have to compile the target. Because it's not, well, first of all, it's not the initialization expression, but we do need to know its name. So the question is how do we... It's really an assignment, or I mean, ultimately. So let's just stub this out better. What we're going to do is we're going to compile the collection expression, and that will leave it on top of the stack. Then we will call the op, well, not op, but iterate opcode, which should turn it into an iterator. Then, and this is what you don't know about yet, the problem with an iterator is that it needs to maintain its state. But, and I'm doing this differently than I've done any other language that I've written. Remember, this is my third one. But in every other one, I've left it on the stack so that I could come back to it. However, in this language, I'm not leaving it on the stack. I am, because the goal is every statement should clean up after itself. So it should not have anything left on the stack. So that means I've got to save it somewhere, which means I need another variable. And I can't just have one, because what if there's multiple ranged for statements? What if they're nested? Okay, so we've got to save it somewhere. So save to iterator variable. All right, and then, so I don't like calling this the iterate opcode, because it's like, you know, get the iterator. Okay, and then save that to the iterator variable, then call iterator, how about next? Iterator next. And that should say, give me the first one. Give me the next one. Give me the next one. And when you call iterator next, it should no longer have the iterator on the stack. It should be the value. And then call iterator next, assign top of stack to the target variable. All right, and then what? if target variable is iterator end, exit the loop. Execute body. What do I call that? Code block. Execute code block. And then lastly, go to execute the code block. That pop result of code block. Okay. Push iterator variable onto stack, go to call iterator next. So if the target variable is iterator end, we exit the loop. So we should set the iterator end target. All right. Now there needs to be something on the stack. Leave something on the stack. All right, and then set the iterator end target. And the last thing is set the iterator end target, set the continue target, set the break target, and is there anything else? No. All right. So that's what we're doing. We're going to come back to this. Yeah, we're coming back to that. All right, so let's go. We are now at this computed expression array, which should be computed expression iterator. So %s array will become iterator. Array will become iterator. All right, and so what all needs to go in this? What is the iterator? It's going to hold some information. The problem is it needs to hold not contents, but it needs to hold like the original value. So a garbage collected, kind of the target, yeah. Target, the collection actually. So the collection, this is going to be the collection through which the iterator what do we want to say? Processes. All right, and collection. So it's going to have a dump, is copy needed. I would think, yeah. We make copy. Do we need to index into it? No. Do we need to slice into it? No. Assign? No. Get it as a string? I think no. And this is going to be the target collection. And it's going to be a garbage collected value called collection. And then we're also going to have the current index. I'm arguing with myself about how I want to solve this. The current index. How about this? Yes, I'm already arguing with myself. What I want to know is I want do I want it to be the previously used index? Sure. And this is going to be, let's just do a size t. And I'm going to have it as the next index. You'll see why. Maybe. I hope so. And index. Okay, there we go. So right now we've only got the iterator, the dump is copy needed, and make copy, and collection. Okay, so this is computed expression. Okay. Computed expression iterator class. I think most of these are going to be able to go away. We'll leave them for the moment. We don't need a vector. We need collection and collection, and then we're also going to add index, and we'll set that to be 0. So that the next one is value 0. All right. And this is going to be it's going to be an iterator. So we're going to return string you know what? At this exact moment, I'm being very lazy. So here's what I'm going to do. I'm going to say pound include, is it S stream? And then this would be string stream feed in what? An iterator, and I want to feed in now this index and then close. All right, and now I just need to put see if it'll do that. So this should create a string stream if I have the syntax correct. We'll see. And then iterator, instead of doing pluses, just feeding it in and say, now give it to me as a string. That should work. And is copy needed? Return. I'm going to say true, yes. So to no, actually, we're not. For right now, I'm just gonna for the make copy, does this need something else? Computed expression iterator and this arrow collection. But no, I don't think we need to even make a copy of an iterator because there's not going to be any way of actually like passing that around. And again, you'll see why in a little bit. Okay, so I don't need this index. I don't need the slice. I don't need a sign index. And do I need do I need it as a string? No. I know there's something else that we'll need, but we'll get there. Let's see, now what? So the this array, we need to, instead of array, it needs to be iterator end. There we go. And what will this be? That the collection has no more values through which to iterate. There. And now I'm no longer over 80. Okay. Do I need... I don't need anything for my constructor. Is copy needed? No. Make copy? No. Index? No. Slice? No. Assign index? No. String? Maybe. Because it well, no, that's a garbage collected. That's a case conversion. As string, yeah, I'll leave it there. And I don't have any private variables. Okay. So let's do this now. All right, so I didn't have anything in my constructor. This is just iterator end. Is a copy needed? Nope, don't need that. Don't need the make copy. Don't need index. Don't need that. That didn't go as planned. Don't need assign index. Okay, so for the string, computed expression string, and we'll just say, what would this be? That should work. All right, now let's go ahead and edit the... I don't think I need to do anything in Flex. Which one is it now? Tang scanner, there we go. Because I'm pretty sure I've got the colon already. In fact, yes, I already do. Okay, we don't need to do... I just quit it. I didn't mean to. I'm sorry. Okay, so now if I edit Bison, our parser, and we need... got all of these. So now no, I don't need anything there. I do need to include my ranged for. Okay, so ranged 4. And what's it going to look like? So a closed statement would be 4. It's no longer an optional expression. It's, in fact... it's going to be an identifier. We don't want it to be 4 open parentheses x plus 3. No. It's an identifier. So identifier, and a colon. Yep, colon. And now an expression, but is this lowercase? And then, yep. And that's going to be an AST node ranged 4, giving us 1, 2, so 3, 5, 7, and I don't need 9. So 3, 5, 7. Now, the identifier is a string. So this should be make shared AST node. What do I call it? Is it an identifier? Identifier. And pass in the 3 comma at 3, so it's location. That should be right. Let's make sure of that. So right here, yeah, it's an AST node identifier. There we go. So there we go. All right, and this is for the close statement. Just gonna save it to see if Bison gives me any issues. It does not. All right, so I'm going to copy this, and that's under the close statement, but I should also have it under the open statement. And just instead of ending with close statement, it needs to end with open statement. And again, Bison should not complain. It does not. It's not telling me that there's any shift reduce conflicts. And yeah, it was still going to give me errors. All right, so where does this put us? Where we are currently is we know that first of all, when we do this ranged 4, we're passing it an AST node identifier, and we only want this to ever be an identifier. So what I'm going to do is, let's go into the AST node ranged 4, and instead of the target being a shared pointer to an AST node identifier. Why not? Just make it intentionally that. AST node identifier, and the target is going to be an AST node identifier. All right, is it not liking that, or is it? Oh yeah, no declaration matches it, but that's because I'm about to change that. So in the constructor now, AST node identifier, that should be just fine. Okay, it still doesn't like the increment, but that's because it doesn't exist anymore. Now, what does this mean? When I have an assign, AST node assign, I just want to look at this. What does it do when it compiles? If the left-hand side is an identifier. We say program get identifiers, the count, and then it's at. Okay, that's what we need. This is the to know its position. It's where it is. We're going to need that. Because now I'm trying to think of what all changes have I made, right? I'm having to hold it all up here, and that's and also make sure that it makes sense to you, right? So I'm trying to explain it as I go along. So what have I done? First of all, flex, no changes. Bison, however, I had to add the new syntax. Okay, I did that. So when it sees the syntax, it creates an AST node. The only thing, we've got our computed expression that is the computed expression iterator, and we've got a computed expression iterator end that's really just kind of a thing that exists just so that we can identify that it exists. That's all that the iterator end is, the computed expression iterator end. The computed expression, we don't have a way of like getting the next value, and we're going to have to add that to the computed expression class itself and then override it for the computed expression iterator. And then, yeah, we'll do that in just a moment. But we still don't have the way or a way of, we don't have the compile for the AST node. So that's what we want to go back to at this moment. So we are in number, I think we're going to be going back and forth between 8 and 2. All right. So we do know that we need to push the break stack, push the continue stack. So the collection expression. So it's going to be this arrow collection arrow compile program. Do we need to save that? No, we do not. Well, I mean, we don't need to save that location. Call the get iterator opcode. So first of all, there. And this is going to be program.add bytecode. So this doesn't exist yet, but that's all right. The uinteger4 opcode that does not exist. And what did I say? Oh, get iterator. Get iterator. And that's because the compile is going to leave it on the top of the stack. Call the get iterator. And in fact, I'm just going to go ahead and do this now. The include opcode. And this is going to be get iterator. I'm going to put it right here. Get iterator. Pop a collection, push the collection iterator. Simple enough. And we're going to make clean just because anytime we add an opcode, something's going to change. So start again. Again, Flex didn't give me any errors, and Bison didn't either. That's always good to keep an eye on. So get iterator is after slice and before cast integer. All right. In fact, I should have stopped that anyway, because we're going to need another one where it's going to be what did I call it? Iterator next. And this is going to say pop an iterator push the next iterator value. Yeah, that works. So get iterator and then iterator next. So program.add bytecode. Get the iterator. Save it to a variable. And what would that be? Well, poke, yes. But then what value do I feed into it is the question. And for that, so the ranged for, it's this. Where is this? And it's the dot name. Okay, here's the problem. Well, no, I'll get that in a second. At, and it is going to be this arrow. Where am I going to save it? So we need an iterator variable name. Yes, that's what we need. That doesn't exist yet. It's about to. So this iterator variable name unique variable name that this iterator will use to persist its state is the right word. State on the stack. And it is going to be a string, and what did I call it? Iterator variable name. Now, we've got to come up with something, and it's got to be something that no one will ever use. That's kind of hard, except we've got an advantage, and that is we are writing in C, or excuse me, C++. But I mean, we're writing in the compiled language as opposed to anyone else is going to be using the the scripting language. And in the scripting language, an identifier must start with a letter or an underscore. It can't start with a number. But since we're writing the code ourselves, we can say, you know what, I'm going to have a variable name and it's going to start with a number, which means no one else will ever use it. Or no one else could accidentally use it in the script. So we're not going to have a collision that way. But then the question is, well, then what's a unique number, right? How do we keep track of that? And all that I'm going to do is I'm going to use the memory location of this AST node. And because it will be the only thing with that memory location. And when we convert the memory location to a string, it'll use hex, which means it will start with 0. 0x and then whatever. And that's fine. I'm happy with that. So we need to add this to our constructor, iterator variable name, and let's do that. So our constructor, iterator variable name, and it's going to be this iterator variable name is equal to, and now I'm going to use the string stream again and if I can't do it that way, I'll figure it out pretty soon. And I need to, I think it's called uint ptrt. If I cast it to uint ptrt this, actually, is that all I have to do? .str? I think so. So what I'm doing is just in a very concise syntax, I'm saying, give me an empty string stream, feed in the memory location, which will convert it into the hex value for me for free, and then give it to me, give it all back to me as a string, save that in iter variable name. Yeah, that should work. On my right hand side, I'm not compiling anymore. So that means in my compile preprocessor, I need to add my variable name, iterator variable name, and I don't remember how, so I'm going to source AST node identifier. And on the compile preprocessor, oh, just add identifier. Wait. It is going to be an assignment. So add identifier and add identifier assigned. Variable name and add identifier assigned. That should be right. And it doesn't like you integer. Do I call it underscore t? I do. Somebody was probably yelling at their screen. Say, Corey, you missed that. All right. So now we've got this poke it into wherever I reserved. That's good. Now, does poke remove? No, it doesn't. So I should be able to call iterator next directly. Program add bytecode u integer t what did I call this? Iterator next, and all right, assign the top of the stack. So this will be a poke again, but where? It's not an opcode. It is going to be identifier at this target, but target is already an identifier, so I should be able to get this target name. All right, now how do we do this next one? If the target variable is iterator end, I don't want to just try to cast it as a Boolean, because a null, the value might be null, and that null is always going to be evaluated as false. So I actually need an opcode that will test, is this actually an iterator end? Do I still have my opcodes open? I do. So I've got get iterator, iterator next. How about test iterator? Pop eval this really should be test iterator end. Pop eval how about is iterator end? Pop eval return no push bool of there. Push bool is val is equal to iterator end. I think that's the best way of going about it. Is iterator end. All right, and I think this is the last opcode I'm going to need to do. So make clean, and now let it go ahead and go about its thing. Is iterator end. You know, I should just just leave that there. And now, so I want to make sure I'm doing this. So I save to the iterator variable, call iterator next, assign it to the target variable. So I've done that. I don't need to reload it. And now I'm just saying if it's yeah. So now it needs to be program, and this is going to be opcode. So jump if true. Really? Where am I? Opcode. So jump if true, and I can either pop or not. All right. So do I want to pop? Yes. The answer is jump if true with a pop. And where do I need to go? We'll worry about that in a moment, but I need to auto is iterator end jump program dot get bytecode dot size. It's the next one. Okay, so I'm saving that because I need to tell it where to jump when I actually know where I'm going to jump. All right, so the code block. Hey, I've done this. Code block. Where's the code block? There we go. There we go. Now, I need to get the next iterator. What am I doing here? This is opcode peak. And what am I peaking? I'm peaking identifier.at this arrow target name. And I need to know where this is. So auto, this is going to be call iterator next program dot get bytecode dot size. All right. What is this going to be? This is opcode unconditional jump. And where am I jumping to? I'm jumping to call iterator next. All right. Otherwise, oh, leave something on the stack because it program dot add bytecode no, I already had that there, but opcode null, just leave a null on the stack. Oh, null val. That's right. It's been a while since I've written this. And now set iterator end target. Where should that be? Where should it jump to? I'm just adding a bunch of lines because I want to put this here. See what makes sense. Okay, so we now know where the code after the while statement, not the while, this is a for. Statement will be. The parent will add a pop instruction. That's right. So account for that by using a +1. Set the target of, oh, this is for the not collection false, but is iterator end jump. Is iterator end jump. There. We now know where a break statement should jump to. So we're going to pop the break stack. Same thing. A continue statement. Where would the continue go? The continue would want to you would have to get the iterator and then call iterator next. So that needs to be right here. Auto, and this is going to be load iterator. Get bytecode size, and what did I call this? Load iterator. All right. Should be everything. Let's go through it. Let's go look through the logic. It's gonna do its thing. So we have to push the break and continue stacks. That's fine. Compile the collection. Get the iterator out of that. Oh, it needs a string. Where is that? Computer expression iterator. And that. Oh. There we go. All right. We get the iterator. We save that away to where it should be saved. We call iterator next. We assign the top of the stack to the target variable. So whatever iterator next returned, we that goes to the target variable. If it's iterator end, we exit. Otherwise, we do the code block, and then we load the iterator again. We call iterator next. Or we go to the iterator next. Otherwise, we leave something on the stack. Is that right? This is after a jump. It will never be called. This doesn't look right. No, the parent is going to add a pop after this one. So we're pushing something on so that it would be popped. However, you and I both know that since there's an unconditional jump here, this null val will never be executed. So that's something that should go away in an optimization run. But for right now, we will leave it there for correctness. And I will say later. It may be optimized away later. That's fine. And now, so the iterator end jump is going to be wherever, past the end of this. And that iterator end jump, where was that? Iterator end jump is, it's popped the value off the stack. All right, so we can jump past the pop, and we know where a break statement should jump to. The break should go to the same place. The continue should go to the to load iterator, and I just want to make sure that that's correct. Load iterator is right here. So if I say continue, there shouldn't be anything on the stack. Sorry, just I was thinking about the stack state at that time. So back to the load iterator. So yeah, when we get to continue, it will then jump to this point where it will load the iterator, call iterator, and then jump to call iterator next, which is up here, call iterator next, and we'll go through. Yeah. That should be right. All right, so it's saying that there's an undefined reference to computed expression iterator is copy needed. I removed that. So where will that be? Computed expression iterator, that's right here. Is copy needed, goes away. Oh, and so does make copy. Now, it's still not going to work. I know that. We haven't written the opcodes, and we haven't written the stuff that will get the iterator and get the iterator next. Two things we need to left to do. But we're compiling again. That's always a good thing after, an hour and a half of writing code. And a lot of times coding is like that, right? You're at a stable state, and then you break everything until you get to the next stable state. And the hard part is you're usually having to hold it all in your head, and that's why it's bad to have distractions at times. But let's see. So what do we need to do? Let's edit the source, not computed expression. I want program. Let's do the dump first, dump bytecode. And we're just going to go down to the end, and we've got these casts end. So I know at this point, instead of slice, I need something else. I need, so that's number 11. Where's my opcode list? Number 9. I've got get iterator, iterator next, and is iterator end. Here's what I'm going to do. I'm going to put the word iterator, because they all three have iterator. And so it's get iterator, iterator next, and is iterator end. Iterator next, and hit a capital I, there we go, is iterator end. Is iterator end. And then this should be get iterator. All right. It's not the computation, but so let's see. Edit the source for program execute. All the casts, there we go. Don't need these. They are just all 1 byte things, but we do need the stack check. So the get iterator is the, well, all of these, yeah. All right, so what we're going to do, so we'll say auto collection is equal to stack back, stack pop back, and then stack push back. Collection arrow dunder get iterator. Now get iterator is interesting. We need to pass it something. It needs to always know, not just, well, wait, no. Yes. Sorry, I'm arguing with myself internally. What all does an iterator need to store the computed expression? We'll come back to this. This is 12. The computer expression iterator. I'm saying it needs to store, but does it need to be something garbage? Yes, it does, because it may go away. So we definitely need to have the garbage collected value. Or that is, we don't want it to go away. So, get iterator, we're going to pass it collection, the garbage collected version of itself. Is that all? Yeah. So we got the collection, popped it off the stack, and then pushed on the result of get iterator. What about iterator next? Well, it's going to be auto iterator is equal to stack.back, and we're going to do stack.pop back, and then stack.push back, iterator arrow dunder iterator next. Yeah, that's all that needs to be done. What about is iterator end? Again, auto this is just a variable, right? Val is equal to stack.back, stack.pop back, and then stack.push back. A garbage collected value, make computed expression bool, and what is the value? It is type ID of val is equal to type ID of computer expression iterator end. Yeah, we're just saying, is it an iterator end? Yes or no? Push that back. That should be fine. So that means I need at the top, I need to pound include computed expression iterator end. But that should work. Let's see if this, oh no. Oh, it's just saying that, yeah, I don't have get iterator and iterator next. That's simple. All that we need to do is edit the include for computed expression. And we need a dunder. We'll put it after the slice. How about that? We'll do, and this will be get an iterator. Virtual garbage collected dunder get iterator const. Is it a const? Well, because I think so. I don't know. We'll see. Maybe not. And then iterator next. Get the next iterative value. Sure. So get iterator and iterator next. Now let's edit the source for computed expression. All right. And we're going to look for the dunder slice. Found it. And this first one is going to be get iterator. And do I need what I'm looking at is when I wrote this, sorry, just moving up a little bit. Get iterator takes a garbage collected value as the collection. I thought I had forgotten that. That's 13. So get iterator. Collection is through which to iterate. Okay, and for that I need now a garbage collected ampersand collection. Just call it collection. Why am I making this difficult? So get iterator will have a garbage collected ampersand collection. You know what? This could be const. Collection followed by a bunch of other stuff. Oh, and I should not have removed the maybe unused. Don't know how to iterate over this expression. All right. And now we need a iterator next. And we shouldn't need anything here. I don't think iterator next can be const. Yeah, it can't be const. But don't know how to ever. Can I leave it as that? All right. Let's see what happens. Will it compile? So I haven't written the iterator or the iterator next for the array, which is what we want to do, but we're close. All right, so on the execute. Oh, it doesn't know what a computed expression bool is. That's a new error. Let's see. Oh, Boolean. See if that fixes stuff. That's my skeptical face. Where's the test? Oh. Why? Because it's in an infinite loop right now. My fan is going like crazy. Why? Because it only exits that ranged for when calling that returns the end, an iterator end. So let's fix that. Let's make it so that it will call iterator end, or if it's an error. I think that's the better solution. That I can do. Computed expression error. Now that should fix the infinite loop. And then the test should fail. Should. Okay. No more infinite loops. Woo. That's good. So, how do we fix it? Well, we need to, in our array, implement the two new ones. The get iterator, and then the what to do with the iterator next. Is that right? What does the iterator next look like? I don't know. I think there's a third thing. No, we can do this. All right. So yes, I was arguing with myself. I'm back, and I don't have the right file open. I need to edit the include for the AST node array, and 13. Just do iterator. And then at the end, add the override. So the get iterator should yeah, okay. Yes, I'm arguing with myself. Here's the thing. I don't like this iterator next not taking anything. And so that's what it is. Okay. So yeah, we're going to just implement iterator next. But I need to know which one. So let's do a size t index. Is index the right word? Basically, I need something that keeps track of which one do I want to get out of it. Index. Index value. So what's going to happen is an iterator holds the reference to the collection, and when the iterator, when the programming language asks for the next value from the iterator, it's just going to turn around and ask the collection value for the next one. Yeah, but I need to give a default value to this. How about that? And now we need to add that to the iterator next. Maybe unused. Size t index. How about that? All right, now get iterator, get, no, iterator next, size t index. That should be fine. All right. So So 13 and, well, 16. So get iterator is garbage collected, const garbage collected ampersand. This is garbage collected. Oh wait. Garbage collected, const garbage collected, ampersand. It's marked override, but does not override. What does it not like? Have I not saved it, maybe? No? Let's figure this out. Get iterator. Iterator next. I'm going to mark that const anyway. I'm going to have a little bit of trouble in a moment, but we'll deal with that. Okay. It's telling me virtual. So the dunder get iterator. Get iterator. And this is in the .hpp, so this isn't even in the .cpp. So it's saying the virtual garbage collected ast node array get iterator const garbage collected ampersand const is marked override, but does not override Are you seeing it? I'm not. I mean, they're virtual. The base ones are virtual. Just gonna, if I yank that, I'm not seeing the difference. That doesn't make any sense. By the way, these should actually be down here. Still not gonna like it though. This is just stupid. Okay, maybe I'm just really tired because we're right at the 2-hour mark, but I'm not seeing where the problem is. I do see the problem now, by the way, in case you're curious. These are not supposed to be on the AST node. They're supposed to be on the computed expression array. Yeah. So, do I already have computed expression array open? No, I do not. Okay. So, edit. Actually. Yeah. There. Get rid of that. Let's now edit the... Well, first of all... Yeah, we'll do the include for the computed expression array. There we go. Get iterator, iterator next. Edit the source for the computed expression array. All right, and then these should be computed expression array, and this should be computed expression array. It's not going to fix it, it's just getting them there. And now let's figure out, it doesn't like computed expression.cpp. Oh, so it won't like this one either. All right, again, I'm not going to be done, but we want to edit the include for the computed expression iterator. This right here. Okay, so that's number 18. So let's go back to, where's our include for computed expression array? Oh, 17. There. So that's the get iterator and iterator next. And dump probably actually is supposed to go up here. I don't remember. And computed expression iterator.cpp, that's before. All right, now, so what are we doing? I need to be able to ask, oh wait, this should be iterator Iterator. All right. So I don't need to be able to ask an iterator for an iterator. So I'm getting rid of that. Iterator next, I will need to do that, but there's going to be a little bit more work that needs to be done. In fact, so let's remove the get iterator. We're just going to call iterator next, and I'm actually going to call this index mutable. So that I can change it in here. So I'm going to say return, whoops, this arrow collection arrow dunder get iterator next, and then pass in this arrow index plus plus. I'm okay with that. So it will increase my index after I get it. So index is 0, and so it's going to ask for the 0th item first. And then it's up to my collection to be able to say, here's an iterator that can iterate through me. And then when here's the next thing when you ask for it. Yeah. All right. So for the array, we're almost done. Believe it or not. We've jumped all over the place, but we're almost done. So get iterator. What we're going to do, this is a computed expression array. We are going to no longer have this maybe unused collection because it's us, or it's a garbage collection that contains us. But we're going to say make a computed expression iterator. And what do we need to give the iterator? I don't remember. Collection? Is that right? Oh, it doesn't know what a computed expression iterator is. We've got to do the pound include for that. We'll need the iterator end as well. All right, so far, nothing's passing. But what we've done is we said when you ask an array for an iterator, it does. It just returns a... In fact... No. This is right. This is fine. The program's gonna, whatever's on the top of the stack, an array, a string, a whatever, it's going to say, give me an iterator, please. And so it's going to, here's the iterator, and it's pointing to the collection. And then it's going to say at some point, hey, give me the iterator next at this index. And all that we need to do now is say if index is greater than or equal to this arrow contents dot size, return garbage collected, make iterator end. That's all we have to do. Else, return this arrow contents sub index. Yeah, that should work. Okay, so we only got a 1 out of it. We only got a 1 because we haven't written, the iterator doesn't know what to do. But it did work for the first one. But it doesn't know how, well, wait, does it? Shouldn't it have worked? I want to double check the computed expression iterator.cpp. Yeah. Okay. So that and all that I'm going to do is I'm going to say cout index sure, just to see what it prints out. Of course, we haven't double checked the compile to see if that makes sense. So we've only got an index 0, and evidently that worked for the first time, but we're not getting an index value of 1 ever. Why not? That's a very good question. I'm going to leave this here for the moment. I'm going to go, let's look at the test document, because all that I want to do is, let's do cout p1 dot dump bytecode. See what it prints out to be. See if it makes sense to us. All right, so we've got a null val, null val, null val. That's going to be A, that's going to be num, and I'm assuming that is our iterator placeholder. Integer 1, integer 2, integer 3, and then array of size 3, poke that into 0. Pop it. Okay. Peak 0, so load A, that's this here. Get the iterator. Poke that into 1. Okay. Is this right? So get the iterator. Poke that into 1. Iterator next, poke that into 2. So the iterator is stored in 1. Iterator next is stored in 2. That's the first value. Is iterator end? Yes or no? Jump if true to 35. That's pretty far. Why? Should only be 34. We'll come back to that. Peak 2, that's the value num. Print, pop the result of print. Peak 2, that's wrong. Because if peak 2 is num, peak 2 should be the iterator. Peak Poke 1. So peak 2 jump to 19, which 19 would say iterator next. Okay, so I think this peak 2 is where the problem is. So that's going to be in the compile of our AST. Peak. This target name. Nope, it shouldn't be target. It should be iterator variable name. See if that fixes it. I'm still worried about the why are we jumping so far past. The test passed, though. That means it printed out 1, 2, 3. It iterated through our array. That is good. That's great. Okay. So the only thing that I'm worrying about is this jump if true to pop 35. Why is the array we know where the code after the for statement will be. The parent will add a pop instruction, which it did not. Why did it not? The ranged 4. Oh, why did it not? Because where's the test? There. Because it is the last result. It's the last thing in the code, and it shouldn't pop it off. So that means that's okay. We can account for that in the grand scheme of things. That means the compilation is correct. In fact, here's one for us. A double thing. So we're going to say outer. And now we'll say for inner in outer print inner. And that should be print out all the numbers. Well, I mean it, poked all of that. Actually, this is still kind of fun to see. Now look, by the way, we've got a bunch of null vals, placeholders, and we're evidently before the jump. So peak 1 should be one of them. There should be another jump T. Oh, wait. That's going to be... Yeah. Yeah, so 1 and 3, I think. Anyway, but hey, that means they're being stored separately, and it's saying, hey, I created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 instead of 1, 2, 3. But 1 through 10 is what I expected it to be. So that's good. Yeah, I like seeing that. To pop to 74, and that is okay. Let's see. This should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so let's write what these are. This is a through an array. This is a two-dimensional array. That's fine. This is going to be attempt to iterate through a non-collection. And so A is just going to be three. Oops, undo. Outer A. Let's go back to num. And this should not print out that. It should be an error. In fact, oh, I've still got something doing an index. Where is that? I don't even know. I think it's 18. Yep. Now I want this to be a get result, and this should be an error of some sort. I don't remember what the error message is, but I'm about to find out. Don't know how to iterate over this expression. Good. Now that should pass. And it's passing. That's good. What else? Break. So what we're going to do is we're going to say if num is greater than 5, break. And it should be 1, 2, 3, 4, 5. And it did 1, 2, 3, 4, 5, and then it broke. That's fine. Let's do continue. Okay, and this time I'm going to say if it's less than 5, continue. So it should give us 5, 6, 7, 8, 9. Yep. All right, and now we could do something like two-dimensional. Let's put it here through a temporary array. How well? We're going to do this. And we'll do this A2. Should give us the skips. 1, 3, 5, 7. Yeah, 1, 3, 5, 7, 9. And at this point, I think, I mean, we've done the majority of the stuff. We don't have strings yet. We can add that later. But we've done a huge amount today. In fact, we're about to look at everything that we've added. But we've got break and continue working with arranged for through arrays. That is good. So here's what we're going to do. On the left-hand side, make clean. Start from scratch on the that's fine. Wait, range 4? Where is that? Oh, no, that should not have there. Oh boy. What do we have different here? Okay, make file stuff, exactly what we expected. Bison, our grammar. Computed expression array, needed that. Our opcodes, our computed expression, the defaults for get iterator and iterator next. Computed expression array, get iterator and iterator next. Our dump bytecodes for get, we saw that working. And oh, sorry. Our execution for these, our tests. All right. Let's see. I know you don't normally do that, but add ranged for support to language for arrays. How about this? For computed expression array. "447 lines. Yeah. And I can feel it, by the way, in my forearms. Oh, it's how I know I'm getting old. I didn't used to have issues with that. I guess I type too much now. Doing our make for docs. And while we're at this, what episode number are we on? I always forget. Episode number 53. Ooh. Nope. For episode 53. All right. Episode 53 is done. Oh, that was a big thing. That was a big part. But when we add this to strings, this is going to be so much easier. I mean, it will be. All right, so where does this put us? Clock. Oh, 8,300 lines. Yeah. 2,600 lines of comments. Still an okay ratio. But again, remember, we've got it against us that we had to do that like 1,000 lines. So, yeah, that's not good. Well, I mean, it is what it is. It had to exist. All right. Having said all of that, I think you and I both have earned a break. We're going on about 2.5 hours, and it's about 1 a.m. for me, so I gotta finish up. But like I said, we've made good progress, and next time we can add support for strings. It will be very simple compared to what we just did, and we might, because I have a feeling that is generally going to be a very short video, we'll probably do a little bit of cleanup that I've been putting off, but that's the goal. And let's see, is there anything else? I don't think so. What's coming up next? I mean, aside from that, is I want to start looking at supporting objects and named objects, not inheritance, not polymorphism, not anything like that. We could, but that's really more than I think that this language should be handling. But we need we've got our functions that are defined using the AST, right? Compiled functions. AST. They're compiled in our bytecode. But we don't have support for functions that are native, especially those that are bound. So right now we can't say, string, tell me how long you are, right? How many graphemes are you? Or how many bytes do you take up? Things like that. We can't do that yet. And so we want to add support for that, because once we do that, then we can create ways of maybe appending to an array, for an example. And yeah, that's the goal. That's what we want to do next. And with that in mind, yeah, we'll be coming back. And as always, thank you. I hope it's been helpful in some way. All right. Bye.